You gave it to me already. Now, the thing about this is not high tech. And I tell my sports medicine guys, it's just like you guys, sticking a hole to put your scope in. It's that kind of maneuver. So with the leg flexed like this, you're less likely to hit the meniscus or any structure. And so I just make my skin incision. And then what I do, I just stick it straight in the joint and cut up, away from the meniscus. And I go right on in, and that's the incision. If I can get my scalpel blade in there, then I'm it. Then I take my finger and make sure I'm through and got enough room. If my finger won't go in, my nail won't go in. I'll get a little bit more right here. Okay. Now, if you let me have the interportal tool. Now, what I do here on the nails, I don't use the handle at first. I used to use the honeycomb. And you just take the honeycomb and stick it into the joint. Okay. But if you come around and give me a shot. And I found this is a little bit easier than using the interportal tool right off the bat. Okay. That's how it works. You can get us a shot there, Kelly. Yeah, could you, push him in just a little bit. All right, let's see if I can find this. Okay, shot there. So usually when I do this, it'll come pretty much close in. Shot. Now, if I'm over this, I'm probably a little anterior. Okay. I'm going to put this in just to catch it. Shot. And I go in about to the old fascial scar. That's about how far deep I am. So let's see a lateral. So now I use this again as that repelling the same. I use a 2-pin technique for all my nails. So I can put the first one in just to see where I am and then drop the next wire in the right place. So I'm anterior. You can see Herzog's curve. So with the honeycomb, I can now just drop in the bottom, make it parallel to this first pin. Shot. That's going to be a little high. So I'll go in, 2 centimeters, pull out the top pin, rotate the cam again, 180. And so this will pull me down. Shot. So now I'm getting closer. Shot. So I'm right at the edge. You see the little Blumensaus line edge though? So to be perfect, I really like to have it right on that spot. So I'll rotate one more time. Let's see if it's this here. Shot. One more. Just for fun. Shot. 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 Again, I take it about to the fascial scar. That's how far I go in. So now, got my portal. Shot. I'll check my AP again. And now I want to take and put my interportal tool in. And I do this for a couple of reasons. If I put this in, take it in the joint. Shot this. Okay. I'll take the honeycomb out. I've now got a tube that goes into the interportal site. Normally I hook suction at this point. And then what happens is the blood, the debris that comes out of the femur ends up in this tube. Also, the aerosolized blood from the reaming stuff that's got the HIV and the hepatitis stuff, it gets pulled into the suction so I don't have to breathe it. So I think the suction thing is a nice safety feature. Could you tie the back? Thank you. All right. So now we use the 12.5 reamer. Goes over the top. Now, the reason this is flexible because it's the same one that's in the channel reamer set, and we also use it with tibia. But whether you're using a straight reamer or whatever you want to do, the important thing is that you create a correct trajectory in the femur. So I'm going to start in. Stop. Stop. Now, if I don't watch myself, what will happen, is I can go into varus or valgus. So, shot. So I'm going to follow this, shot, and make sure that I'm going straight up the canal. Okay, go up just a little bit higher, Kelly. That's good, pal. So now I've got a better idea that I'm centering this thing, because I want this trajectory to be straight. I'm going to go all the way down, and you'll notice I buried this. Okay, shot. Now I see a lateral. So with that view, I've got a pretty good idea that my initial trajectory is correct. I don't have the fracture in varus or valgus. And that's the real problem with these distal fractures. The reducer next. So there's our guide in. You push in toward me, Kelly. Just push in toward me. Shot. Yeah, so I'm okay with that. Pull it out. Let's have the reducer. Long stuff. So we talked about this reducer. The reducer is curved, number one, because it matches the curvature of the femur, if it's a 2-meter radius. Second thing is I can use this to manipulate things to help reduce the fracture. Shot. Shot. Now come down to the knee, buddy. All right. So there I'm coming in. Now I want to show you this. Now go up a little bit and take a picture. So a little bit more. You see how I've got a slot orientation? So I'm doing this like a ski tip. So when I'm coming off the bone, I like to think of this as a ski tip, and I'm going up on the bone so it doesn't go out. You want to keep it up with your tips up till you get to the fracture site, and then go up a little higher. Shot. We talked about this yesterday. The way you use this is like you use a finger taking a marble out of a glass. You take it in, grab it, and hook it. So I can actually rotate the reducer. Shot. Okay. And then I can cam it. Shot. Shot. So that's how I can get things reduced, moving this thing around. Okay. So it's a very facile way of getting the reduction. Now, retrograde femur, I take it up to this black mark here where the connecting is. Go to AP of the hip, buddy. Yeah. And it'll be about right here, Kelly. About right here. That's good. Now you see the lesser troche? I like to bring the guy wire to just around the lesser troche area. I like to leave a little room at the top so if there is some kind of future fall, I've still got an option to fix the hip. Shot. All right. Show me the hip better, buddy. Shot. All right. So about right there is usually where I stop it. Now, you saw how easily that spreads up. So what I'm going to do is maintain that position. So I'll take this operator tool and use it to keep the wire in the same place while I'm pulling the reducer out. Shot. Push it in a little further. Shot. Now take the ruler. When you're assessing the length of these things, you want to make sure that you're going to be able to countersink this nail in the knee so you don't have any patellar irritation. So we'll take our little depth gauge ruler. I've got my guide wire where I want it because this thing actually hits the guide wire. Shot. All right, so that's good. Now I come down to the knee, Kelly. And then go to a lateral. I like to assess the length here on a lateral x-ray instead of the AP. Anything you want to jump in and say about it? Feel free. Come on down to me, Kelly. That's good. So you can see the ruler sitting off a little bit, right? So if I chose that reading, I'd probably be a little bit long. So I'm going to look at this and say, okay, I want it to be, or this is saying 46, so I'd probably take a 45 nail. In the meta nail system, there's centimeter increments instead of 2. You know, almost the other nails, we have a 2 centimeter spacing. But in the metas, we found that you need that 1 millimeter spacing for precision. So I'd probably take a 45 nail to have it ideal. Now, I've already reamed the proximal end. So the top of the nail, I don't have to ream anymore. The only thing I have to ream is the shaft. And you all saw the reducer when I had it down, I had bone on both sides. The reducer is 8.5 millimeters, so I'm probably going to be okay with a 10 or 11.5. That's my two choices. So I'm going to start with 11 reamer first, right? Because if I get chatter in the isthmus, then a 10 nail will be okay, and I've over-reamed a millimeter. The way that works is these reamers are kind of football shaped. You can see this here. They're kind of, I don't know. Is that better? No, that wasn't better. They're kind of football shaped. So they'll actually lead in as opposed to the old square type reamers. So, drop this guy down. Hardest part of the case, getting the wire. You didn't get the wire on it? All right. Now, I'm pushing all the way in, and X-ray at the hip. I didn't get any bone, right? So if I put a nail in that was a 10, it would be translationally unstable. It wouldn't be strong enough, right? So I know that's not going to do it. X-ray. Right there, Coach. Now I'm hearing clatter, shot. And that's in the mid-isthmus. Shot. So I'm probably okay with a 10 millimeter nail up in the top end. It's just that down below, I don't have much stability, right? So I might have to rely on my screws or a blocking screw, or I'm going to have to go to a bigger nail. But I'll probably get more bang by using a multiplanar nail. You got a 10 nail? Oh, in that case, give me a 12.5. Yeah. Cheating and not using the operator. They're going to fuss at me. 12.5. So most of the time, I can jump up a millimeter and a half pretty easy. But if you notice, I rarely ream more than twice. You know, the old days, we used to start with a 9 and go 9.5 and 10, 11, all kinds of stuff. That's because we didn't have the entry portal tool making the proper cut up here. And so we were cutting the metaphysis and the isthmus. Once you've cleaned out the metaphysis with the newer techniques, you only have to clear out that 2 centimeter isthmus area. And you've got the reducer to tell you. So you really can be a lot more conservative. You can be a lot more conservative with your reaming. So that's the proximal isthmus. X-ray. All right. So we'll pull this out. All right, so now we're ready to put a nail down. Get that? Got it. Just hand me one thing at a time. All right, so now I've got this assembly. Now, first things first. If you look at this nail, it's got calibrations, so you get an idea how far you're going in. These are centimeters. If you look at the edge of this platform right here, it's in line with the top of the nail. So when you're putting this down and you're trying to figure out where your nail is, you just look at this handle, and that gives you a representation. You know the joint line is going to be somewhere just around the patella. So once you get this started, you don't have to take an X-ray until you get it close to being seated. And that'll save you a lot of X-ray. Take out your interportal tool. It's always lifting up to get them in. I'll work it through the isthmus. So this is no problem. I'll take my impactor. I'll pull my guide wire out just like you guys always do. I think once a year I leave it in just to remind myself that drills won't go through guide wires. Now, see, a lot of guys start taking x-rays right now at the knee because they don't know where they are. But I know my nail's right here, so I got to keep going. All right, come give me a lateral of the knee, buddy. The way I judge this is by the lateral x-ray. Raise it up just a little. Stop. Now, if you look at that, you can see the first little notch corresponds to the nail junction. So it's countersunk now. And if you look at the calibrations on the guide, that's 10 millimeters. So this is countersunk somewhere between 5 and 10 millimeters, which makes sure I'm not getting patellar impingement. Okay? And so I was able to do that by just referencing the top of the patella. Okay? All right, so now we're going to go ahead. We're going to do the sure shot, but I wanted to show you the blocking screw stuff. For the guys that didn't see it, do you have the reducer, the blocking screw? I was supposed to put that on first. So if I had a very short fracture here, approximately, when I had the reducer down, I would have stopped and stuck this clamp on. And the way this blocking screw guide works, it's just like a total knee template when you're making your cuts. So, thank you, buddy. Snap it on. All right, let's see if we can get it. Oh, I see the problem. Okay, now, what you do with this thing, you put this blocking screw guide, zoom out a little bit, Russ. So the reducer's in, and so I drop this in. This is a 11.5 nail, so I'll choose the 11.5 block. And now you see these holes in gold sleeve. So if I want to put a nail or a blocking screw in, I can just drop this in, put my blocking screw before I put my reaming and nail down. Okay. If I want to do a medial blocking screw, I just rotate it. The nice thing about these guides, it puts the blocking screw in exactly the right place, right? Because if you ever see guys blocking screws, when they're trying to guess where it goes, there's always 2 or 3 attempts to get it right. So, instead of doing freehand cutting for total knees, we use guides now. And so this is just a guide for that, okay? Is everybody pretty clear on how that works? One of the questions is, where do I put the screw? If you're looking at the fracture from the way the nail enters, right? Wherever the fracture is closest to the nail entry point, that's where the nail wants to head, right? And the way you remember this is that nails are like teenagers. They want to leave home early and come home late. Everybody got that? You know it's true around the world, right? So here's the idea. If I've got an oblique fracture, the very first chance that I've got for the nail to go out is where it wants to go out. So I need to put my blocking screw on that side. So you put mom on the front door and dad on the back door. All right? That's how it works. Everybody clear on that now? So you look at any fracture obliquity, the closest thing to the entry port of the nail, that's where it wants to come out. You put your blocking screw right there in front. And then that forces the nail to stay in the center. Keep the curfew. All right. So our nail's down. Now we're going to do, let's have the black guy. We're going to do the sure shot, which is the targeting. And what you have to do right now, the sure shot is a 3-dimensional targeting system. It works by putting a probe through the nail. So you can't do your proximal locking here first. Now I went to a lot of trouble to make sure that I've got the nail countersunk in the right place. I don't want to lose that. So I take the blocking screw guide hole, I need the drill and a gold sleeve. And what I'm going to do is I'm going to lock this in place so that I don't lose my depth and rotation. Got a knife? I have one up here. Okay. So I'll put this in, and then I just run a 4-millimeter drill bit. Almost about the same incision we make for the semi-extended. Thank you. So we'll take a 4-0 drill bit. All right. So now I've locked my rotation. I've locked my depth insertion so I don't lose my placement. And that's really important to do this step. All right, so now we're going to pull the sure shot in. So the sure shot, for the guys that weren't here yesterday, is 3-dimensional imaging. So we create a program where the computer develops a 3-dimensional world that represents the nail. There are 2 sensors. There's a sensor that we put inside the nail. This is the probe. And to do that, I have to put it through a locking guide that sits the length of the nail. Because the probe doesn't know how long it is. So we have to tell it. So you take this guide here, this sits on, and you screw it down in place. It's loose. Yeah, I wonder if I've got some junk in it. You have another one? You have another one? This is not going down. Maybe. Yeah, I think it's got some bone junk in it. See if I can clean it out. You have another? Yeah. Looky there. Takes partner. That'll help. All right. Because this is kind of part of the critical part of the technique. This has to be firm and stable, otherwise your accuracy will be diminished. So now I've got it stably locked. There's a button I push right here, and when I do this, it opens up the gantry. So I'll take this nail. You see it has different colors. See it's on 24 today? So there's the blue guide. So this is for a retrograde meta nail. Okay? So I take this guy. It's got calibrations along here that tells lengths. So I find out what length nail I'm going to use, put the sensor in. Now you see how this thing is curved through here? And what that is, that curve is the opposite of the femoral nail curve. And so when it comes in, it forces the sensor on the anterior inner surface of the nail. If the nail bends or moves, the probe tracks with it. So that's how we keep it centered. So I'll put this guy in. Almost got it in. There we go. All right. 24. So I'll set it to 24. Got it. All right. So when I stick it in, it's stuck, right? That can't be moving at all, or you'll miss. And I can read the 24 number, so that tells me for this one, that's what I've got. All right. I'm all set. Now what we do is we turn on the computer. Actually, the computer would already been turned on. There are two inputs. There's one input for this sensor that the nurse just plugs in. And the second input is for the targeting device, which is really an electromagnetic field generator. Okay? We call it the targeter. So now we're going to switch over. This is the computer screen, what it looks like. Takes 30 seconds for it to boot up. And then what we're going to do, we're going to use the computer screen like a touch screen, like an iPod. And so what we'll do when it comes on is it'll go through options. First, it'll verify that our probes are set up. Now, you see the two options, the sure shot probe and the sure shot targeter. So we'll plug in the probe. The probe is calibrated so the computer will recognize the correct trajectory of the nail, right? Because each of the nails has a different computer program. So this says meta semi-extended. We're doing a retrofemoral nail, so that's why we had to change the number to matches. But normally you want to have your probe matches what nail you're putting in. Then it's the exact reading. Okay? We plug that in, and then next thing we're going to plug in the targeter. And the way you know it's targeted is that you'll see the targeter go orange. And that takes about 5-10 seconds. So I recognize the targeter. So at this point, I choose a short sleeve or long sleeve. This guy's kind of thin, so I use a short sleeve today. So Greg will touch short sleeve. The next thing he'll do, we're doing a retrograde femoral nail. It's 11.5, so he'll touch 11.5. So now the computer boots up. It knows which nail we're doing and which program. So now I take this short sleeve. Let's see, where do I need to be, buddy? Need to be probably right here in the, can you give me this picture here? Overhead. Yes, sir. 11.5. Oh, we're using a 32 nail, but I don't have the correct probe here. So I've corrected for the semi-extended. That's why I put it on 20. Yeah. The way you should have it, you should have the correct probe, then it's the nail reading is the guide reading. So we're fudging because we don't have the other probe. All right, so now I'm going to screw in this device. So this does three things. The targeter finds the screw, tells me where the skin incision is. So it finds my perfect circle. Then what it does, it lines up my drill to drill the perfect circle. And the third thing it does, it allows me to put my screw in to the perfect circle. So three functions. So the first thing I'm going to do is come up here to the leg. And you'll see what happens is it's a three-dimensional world. As I come closer to the nail gets bigger, just like you walk up on a building, okay? Now, right now, the orientation, you see the green and red. You see some white lines, okay? The nail is not going the way I think in my brain. I'm thinking the end of the nail is up here. So you ask your assistant to touch the screen and rotate the nail, other way around. So the nail tip is now pointing to my left, which is what it's supposed to be, right? So left is left, right is right, anterior is anterior, posterior is posterior. So with that reference in mind, I put my hand on the leg and the guide. That locks me into the body. I translate with the green I rotate with the red. And that's my perfect circle. So now what I do is dent the skin, and that tells me where to make my skin incision. Make the skin incision at this point, just a straight stab. And now what I do is I take my drill. This is a non-magnetic drill tip. Stick it through the sheath. And then I push the sheath and drill bit down to bone. So I get it on. In this position, I got my hand on the leg. I got my thumb and index finger on the sheath. So that's how I move the green. And then I'll use my right hand to move the red. Okay? So now I'm going to go up, over, rotate in. I'll pull it back a little bit. And now I'm targeted. You see the little red arrow that's in there? As long as that red arrow is going through, I'm going to target that hole. So having found that, I'll line it up, start drilling. And the thing, you see how it moves around and jumps? It doesn't matter because I can still move it and correct it in real time. So now I'll come back to the real target that I want. I'm going to show you I'm off about 10 degrees. But as I come in, I can fine tune it through the bone. Jumping all over. I don't think it's frozen. I think it's just dull. Has it been used before? I'll keep drilling. Okay. So I came in to see my target. I'm off a little bit. And I'm showing you this. I'm on the far cortex now, and I can read the depth of the screw here. Okay? So I'll look at this on the far cortex. Let's say it says it's 40, and I'll probably put a 45 in. Now, just about always up here, it's a 35 in males. So I drill them through the other cortex. Okay. That drill bit's gone. Okay. All right, I'm done with that hole. 35 yeah, 35 screw. So I'll take off my sheath, and I'll get ready to load up my screwdriver. The screwdriver is also non-magnetic. I'll show you about the magnetic fields in a minute. It's a capture screwdriver, just like the Trigen stuff. So you actually assemble the screw on the driver, put it through the targeting device, and then drop in. Now I'm going to show you this again. So here I've got the field coming in, and you'll look at it. I've got the green on place. There's the red. All right. Now watch what happens as I move the targeter closer to the leg. It'll actually go all the way through the nail. You see the green's gone through. Now the red will go through, and then you lose the nail. So as far as the target's concerned, I went past the nail. So that's when that's three-dimensional. It's not just sitting up on a plane. How you adjust the height makes a difference in how you view the nail. Okay? If I want to go sideways, I see a lateral view of the nail, right? So there's no holes there. Okay? You can orient the screen again, so I'm still oriented correctly. I come back to the front, and now I'm looking at it directly on, and there's the holes. So it's a three-dimensional representation of the nail. Okay? So I'll take my gold non-magnetic screwdriver, take the Trigen screw, stick it in. So I'll do again, green to translate, find my hole. Okay. And you see my red arrow? Normally I would be just like that. I'm a little bit off axis. Let's see if I can get it fixed. Nope. Battery or what? Do you have a T-handle? Shot? Oh, shot. Isn't that a habit? Did you hear me do that? That's embarrassing. All right. Give me an X-ray. Yeah, right? So I'm going to target this over. I'm just a little bit off the side of the screw. And I want to show you this because as long as that arrow goes through, it should be in. Let's see if I am. Off, over, and pull it over. Now, you have the drill bit. I'll put the sheath on, and now I'm going to show you the second screw. Shoot. There we go. Yeah, the stuff's kind of falling. And I'm going to put a second drill bit in. I need that sheath. I'm going to drill a second hole, and I'm going to put it down precisely on target this time. Got a knife again. So now I'll come back in here. There's the green. That's where my hole will be. About a breath. So that's spacing. Now I've got a sharp drill bit this time. I've been assured. Brand new drill bit. All right. It's a brad point drill. I'll probably take this off out of the way. Thank you. Thanks, Mike. All right. All right, same thing. Move my green till my green is perfect. Rotate for my red. Move my green, translate it. So now I'm dead on. So when you kept that one, it just kind of drops straight on through. So sharp drill bit's very important. Let's have another screw. Green translate, red rotate, move it off. So if you notice that it jumps around a little bit, but as long as the red arrow is pointing into the hole, it's going to center it. All right, now, Kelly, come on back, give us a picture, buddy. Now, the sensor probe is actually about 2 centimeters above the hole. So you're never going to drill through the probe, okay? If you're having trouble targeting anything wrong, 99% of the time there's probably something wrong with the sensor probe. And if you guys are ever in a situation where things just aren't lining up or whatever, take the probe out and replace it. Get another probe in there. There's no charge for that. You know, they send it back and they analyze it. Go on right up here, Kelly, to the top. Shot? All right, come on up. Yeah. Can you give me a big picture? Yeah, full screen X-ray. All right. So both those are filled. Let's see a lateral, Kelly. So the point is, I showed you, even if I'm 15 degrees off axis and that little red arrow is in the hole, it'll still be able to get in there. That's how accurate it is. You get it lined up perfect, it just drops straight through. Okay? You also saw the importance of a sharp drill bit. All right. Shot there. So there's both our screws. Going a little bit further. Okay. So the really beauty of this thing is the accuracy, and that's pretty common. How long it takes. You know, in 5 minutes you're done with both screws. There's been no real X-ray except the check, and now I come back over here, and now I'll lock in my fixation here. Then I pull out my blocking the guide pin, and now I've got everything reduced right where I want it, and nothing's moved. Okay. So that's the sequence we're using with this. We're working on designs where you can put the sensors in the nail, so you don't have to use the probe. But with the FDA, it may be 3 to 5 years before we get that. So we're working with this now, and this is what we're releasing. It's applicable to the metafemoral retrograde nail. It's applicable to the metatibial nail, and it's applicable to the tan nail. is what the systems, the 510K approval by the FDA has been granted so far. And then the next two projects we've got is the humeral nail and the intertan. So it'll be a while before we get those other two out. But this is what we have right now. Any questions about the sure shot, the retrograde portal, the reducer, the blocking screws? Any questions? Yes, sir. Yeah. Well, the idea is I want to use a nail that controls translational motion, but I don't want to take any bone that I don't have to. It's called bone conservation. Okay? So when I first started nailing, for males, we did a 16 to 18 millimeter nail in men, which we'd ream away half of their cortex, right? Well, that never comes back. So we've actually left them metabolically with less bone than they should have when they reach 60 and 70. So the idea with this conservation stuff we started with the RT system was you only ream enough to get the nail in, because we've made the nail strong enough that we don't really worry about failures now. The real reason for reaming bigger was to put a stronger nail in. Now we've been able to make stronger, smaller nails, so we just want enough reaming that the nail will go in and be translational stable. So put the reducer down, look at the size, and you can estimate, is it a 10 or is it 11.5? Most women are 10s, most guys are 11.5s. And basically, if you've already reamed your entry portal, then all you're doing is 2 centimeters of reaming. That's minimal thermal necrosis, that's minimal bone loss, and it's minimal speed. So you can actually cut 15 to 30 minutes out of your operation with a 2-pass ream technique. Yeah. Yes, sir. Actually, I could do a blocking screw up here. I don't have it calibrated the system to do a blocking screw up here yet. But the deal is there's 2 types of blocking screws. There's trajectory blocking screws, where you put the screw in before you put the nail down, so the nail goes in the right direction. Okay, that's the most common. And then the stabilization blocking screws. Let's say that this canal was 16 millimeter diameter. Well, I put 11.5 in, so I've got 4.5 millimeters of space around it. So if I put a blocking screw to